This is part 5 of the video about building a simple database along with two SQL statements, a select and an insert. Tools used to create and populate the database will be DBBrowser and Python. This fifth part is about building and testing SQL queries acting on the test data entered using DBBrowser. I'll briefly recap the previous steps about defining and normalizing the film and actor entities that will become tables in the database. First step was to define the actor and film entities and then normalize the many-to-many relationship via a linking table. The primary and foreign key values were defined within the appropriate entity. Then the test data was defined: actors, films, paying special attention to the values put into the actor-film linking table. Tables were built in DBBrowser and the test data inserted. So now we have a test database containing 3 tables, each of which have test data in them. Now I need to create and test an SQL query against the test data. The particular query I want to run is select all actors whose date of birth is before 1950. All the data necessary to satisfy this query is contained in the actor table. The SQL command will be a select. Select all actors from the table actor. The date of birth is before 1950, which will be achieved by inserting where date of birth is less than 19500 0000 on the select statement. I suggest while a select statement is being created that a select asterisk I suggest when a select statement is being created that is written initially with select asterisk so that all data is seen, then later filter to the fields required by replacing the asterisk with the field names. To build the SQL statement in DBBrowser, open the database and when open, click on the Execute SQL tab and type in the SQL. In DBBrowser, open the tab Execute SQL. Type in the required SQL select statement in the first line. While the command is being typed in, DBBrowser software will suggest potential values by performing a pattern match on keywords or table or field names such as from, where, and actor. In this case, select the actor table name and insert the date condition for the field DOB within the database. This suggestion and auto-completion helps avoid typing errors of the names of tables or fields. The word entered has a particular color. In this example, the table actor is colored in turquoise, whereas the field or column name DOB is colored in purple. Once the SQL statement has been typed in, I press the right pointing triangle, causing DBBrowser to try and execute that SQL statement. The SQL statement output all columns from the actor table, actor ID, name, nationality, and date of birth. In addition, this transaction selected only those date of birth values that were before the beginning of 1950, guaranteeing that those actors were selected. When this SQL transaction was run, the database contained 5 actors whose date of birth was prior to 1950. The window at the bottom of the DBBrowser screen indicates the status of the execution of the SQL statement. What you want to see is the SQL statement ran and completed without any errors, indicating the SQL itself had no syntax errors and it didn't have any logical inconsistencies or conflicts with the definition and structure of the database. The database returns the data that the statement executed in 97 milliseconds and returned 5 rows of data. Having successfully executed this SQL statement, I want to retrieve the same data but filter the output so only the actor's name is displayed. This filtering of output is simply achieved by replacing the asterisk with the name field, and in DBBrowser it indicates that name is a field or column because when we select it, it is seen with a document with a green line underneath it. This updated SQL transaction is executed by pressing the right-facing triangle. The output is as displayed. You can see the same actors have been selected, but only the actor's name is displayed in the bottom window. DBBrowser shows that the execution of the SQL statement completes without error and 5 rows were returned in 42 milliseconds. A more sophisticated SQL statement is select asterisk from actor where name like Keanu%. That SQL statement will find all actors in the actor database where the name starts Keanu and is followed by any number of characters. The page link to W3 Schools SQL ref like will show you all the options available on the like keyword within the SQL statement. The next stage in building the query is to join the information that spans 2 tables. This query across 2 tables is achieved with an inner join. The query will show the information from the 2 tables actor and actor film, where the actor is Sandra Bullock. Inner join is documented in the W3 Schools website. Note there are other approaches to inner join, principally matching values in fields across tables on the where clause. The SQL statement will take the actor table and inner join it with the actor film table and link them together where the actor ID value in the actor table is equal to the actor ID value in the actor film table. The first being a primary key, the second being a foreign key. The select statement will only select those records where the name is like or starts with Sandra, a name being the field within the actor table. If the field name occurred in several tables, it would be necessary to further qualify the name by preceding it with a table name, in this case actor.name. Retrieving data about actress Sandra Bullock is achieved by linking the 2 tables via their actor ID and then filtering on the name Sandra. The percent means that all records where the name starts Sandra or is Sandra followed by any other number of characters. Executing that SQL query, DBBrowser returns all of the field values across the 2 tables because of the select asterisk and inner join. The reason that 4 rows are returned is that Sandra Bullock, with an actor ID of 3, occurs 4 times within the actor film table. Each one of the occurrences of actor ID equals 3 is paired with a different film ID in the actor film table. In this case, film IDs 11, 4, 17 and 20. The actor film ID AFID is the unique identifier for the pairs of foreign key values, actor ID and film ID, within the actor film table. The AFID value is not required or used within the SQL select statement. The highlighting shows the pairing between actor ID in both the actor and the actor film tables, where the actor ID value, or actor whose name starts with Sandra. But we don't want to know the film IDs, we want to know which films a particular actor appears in. We want to show information from the 2 tables, actor and film, where the actor is Sandra Bullock or starts with Sandra. To achieve this, 2 inner joins are required. We select all columns by performing an inner join across the 2 tables, actor and actor film, connected by their actor IDs being the same across those 2 tables. On the same select, perform a second inner join to the film table, where the film ID is the same in the actor film and the film tables. The rows are still filtered to select only those that start with the name Sandra. That SQL query generates a lot of data, but the key information is displayed. You can see the actor ID from the actor and actor film tables are the same, the value 3, and the film IDs are the same between the actor film and the film table. For example, film ID 11 in the actor film table matches the film ID 11 in the film table. The film ID of 11 has the film title Speed. To display only the data that we want, which are the names of the actor and the films that actor appeared in, we convert the asterisk following the select to name and film title and leave the rest of the select inner join unchanged. In this example, the field name and the field film title are unique across the 3 tables, so they don't need to be further qualified by the table name preceding the field name. If the field names, name and film title were duplicated across the tables, they would need to be qualified by preceding them with the table name you wanted to extract that value from. To run the same query but for a different actor, the only thing to change is the name of the actor following the keyword like. In this case, I'm looking for those films that in my database Irfan Khan has appeared in. I rerun the select statement and it returns 2 records from my database where Irfan Khan has appeared in: Slumdog Millionaire and The Lunchbox. Notice that the spelling of the actor's name, or part of the name, that the SQL statement is going to match on must be an exact match with the records in the database. If the part of the actor's name is misspelled, then the SQL query will run but not find any matches. For example, if the correct spelling IRRFAN is replaced by the incorrect spelling IRFFAN, no records are found that match this query. SQL is not like Google, where Google will find and suggest close matches if there may be spelling errors in an SQL query. The middle of the DBBrowser screen is blank for this misspelled value, because no records were found or returned that match this particular query. At the bottom of the DBBrowser screen is reported that the statement executed with no errors but returned 0 rows. There is no error in the SQL statement or the field names or the table names coded within the statement. It was just the data value was spelled incorrectly and no data was returned, which is the correct result for this SQL select.